So my name is Jeff Deininger. I'm a systems engineer at ExtraHop focusing on cloud. So it's good to talk to you all today. I actually lost count of the number of times Ryan and Corey said, Jeff's going to show you that in the demo. So I'll count on you all to help remind me as I go through. I want to start with putting a bit of description to the visual of the landing page when you log into RevealX, to really kind of underscore this whole notion of network detection and response. So we've talked a bit about the gaps represented by the strategy that relies solely on SIEM or endpoint detection and response. And so the notion that, as was mentioned earlier, that it really is the network that sees everything that happens in an environment by virtue of the fact that it's the circulatory system for an organization. So when a RevealX user logs into the system, they're greeted with this overview page. And our goal from a product perspective is to really distill down all of the analytics that we're doing into something that's immediately actionable and that the user can take and do something with as little friction as possible. And so the ExtraHop system might be deployed in several VPCs, in branch offices like the Home Depot is doing, in data centers. And so across your entire estate, we might be monitoring billions of interactions across hundreds of millions of devices. And yet, there might be only 18 of your critical assets that ExtraHop has automatically discovered and classified as critical that are worth you paying attention to right now, that have some kind of security event or detection that's firing that's associated with those assets. So narrowing the focus of the analyst to not hand them sort of another like alert cannon that fills up the work queue with noise, but really presents actionable intelligence. So we've prioritized these different detections along a couple of axes. One is for folks that have a cybersecurity background. You're familiar with the Lockheed Martin cyber kill chain model, so the different phases of a cyber attack and how it unfolds. So the radar graph here gives you a count of detections by kill chain stage. Right, so you can see network reconnaissance, exploitation, lateral movement, and so on. You can, at a glance, get a sense of where the hotspots are and where you might want to dig in further. In the middle pane, you see a representation of all of the critical assets that ExtraHop has observed talking on the network somewhere within your environment. This is actually a really crucial first step, this notion of auto-discovery and auto-classification, for two reasons. One is these device representations are the thing that we hang off all of our metrics off of. And so later when we get into a discussion of the anomaly detection, we'll go into some example detections. A lot of those detectors make use of predictive models, right? And if you think about a predictive model, what you're really talking about is having some notion of historical behavior, right? Some baseline, some sense of what's normal, and such that you can make a prediction of how the thing is going to continue to act or behave in the future. And when we observe the device to be behaving in a way that's contrary to what we have predicted, right? That's anomalous, right? So we'll throw a detection. And so we'll get into some examples of what that historical information looks like on those devices. So that's auto-discovery, this idea that you don't have to actually instruct the ExtraHop system what devices you have. As soon as they come online and start chatting on the network, we're aware of them. We start sort of profiling all of their behavior. But then this notion of auto-classification kind of stands on the shoulders of auto-discovery. So being able to understand which of the devices are important, both from an app delivery, service delivery perspective, but also from an information security perspective, is something that the system does automatically. So this notion of auto-classification, that the system is able to, through its passive out-of-band observation, understand what are the most important devices in the environment, both those that participate in delivering line of business applications to end users, as well as there's those that hold the keys to the kingdom and or represent information repositories that contain an organization's most sensitive data. So you see this in the middle part of the screen, and we're rolling up the number of security events, right, by asset class. And then the third pane gives us sort of the scariest detection. So all of our detections include risk scores that are associated with the detection as a result of research done by our threat research team at our Seattle headquarters office. And so you can get a sense for a given time frame that you're looking at, what's the scariest event that's taken place, and that may be where you want to dive in.
How big is your threat research team, and do you collaborate with any of the other big IT companies that also have threat research teams?
Yeah, that's a good question. I don't know that we actually make that information available publicly about the size of the team. And in terms of collaboration, is that something you can take, Courtney?
We have a team that's growing. We do collaborate with a number of vendors, and we are continuing to explore more ways to improve our threat research team. This sounds really abstract, so let me actually make it less abstract. I'll give an example. We just, I think today, we released 7.8, our new version, and one of the things it has is it has updated threat intelligence feeds in it. We are talking with threat intelligence providers to see if we can provide some level of their capability in our product. We also, though, had our threat research team go through some publicly available threat intelligence sources, find the ones that we thought looked pretty good, curate them a bit, and create content to just get our customers who didn't have an existing threat intelligence provider bootstrapped. So that's the kind of place where we collaborate, and we do it ourselves. In the case of some of the emerging threats, we're growing our team because we think it's really important to be able to cover any critical CVE out there, like Bluekeep we talked about earlier, or a WannaCry from earlier. That we're trying to figure out what we can do ourselves and what we'll have to partner with other companies to do, because the exploits and seeing what the traffic look like is one of the hardest things. So yeah. We'd love to make it bigger, and our director of threat research is continuing to grow that team.
Yeah, it just seems with your ecosystem partners that are bigger, and they have huge threat research teams, that because you're ecosystem partners, that there might be some synergy in sharing?
Yeah, it's a great point. Without going too far down the rat hole,
I understand.
It's threat research is really good at finding problems for what our product does in terms of actually finding active exploitation. There's a smaller community, so there are obvious sources like when it's in Metasploit, we know we're going to be able to reproduce it. But for a lot of the ones, the researchers who are doing responsible disclosure, they don't make that data as available. And so we're trying to figure out if there are sources where we can get that information, but we kind of have to show we're the good guys cred to begin with. And even then, there's not quite as formal a structure around it. So it's a great question, because we know it's an area we want to improve on.
So I want to go through a couple of example detections, as well as the investigative workflow that RevealX Cloud offers. And the reason for that is one of the things that we see as a differentiator for us in this product category is the notion that a lot of the other folks in the NDR space are primarily focused or even exclusively focused on detection, right? There are a handful that will focus on things like TCP resets as a form of response. But in our view, kind of philosophically, once you have got, whether you're looking at a security issue or you're looking at a network performance or app performance issue, once you've gotten to root cause, what the correct response that you should take, fairly self-evident. The tricky part is figuring out what is the right response to take. And this is going to vary, even for the same threat or the same type of network performance or app performance issue from one organization to the next. And so Well, one of the things that we've done in the product is provide not just detection capability that comes from analyzing extracted metadata from packets, but also a powerful platform for investigation so that an analyst can actually dig in, get the appropriate level of context that they need to properly characterize the problem, and then the user can decide what form of response they're most comfortable with, ranging from a fully manual response where someone goes and modifies a config on a machine or an ACL on a firewall, or, yes, go ahead.
Yeah, when you state the extracted metadata from packets, which awesome. But what mechanisms do you have for inspection and introspection on traffic that's encrypted, or SSL, TLS, blah, 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 standard things, or, what mechanisms do you have to actually go and inspect on that?
Yeah, fantastic question. So this is actually a good lead into the two key prerequisites for being able to do any type of network detection and response meaningfully. Now, number one is you need to be able to actually ingest crazy amounts of packets, right? So Corey alluded to the notion that a single 2U EDA appliance can drink in 100 gigabits per second, right? The second thing you need to be able to do is you have to be able to do something with those packets, right? And so that kind of breaks into two categories. One is you have to be able to parse out the protocols, right, that devices are using to speak to each other. But that only becomes relevant at the point that the traffic's not opaque, right? So you've got to be able to decrypt it as well. So I appreciate the question.
But if you can't decrypt it, what type of introspection can you do around that, assuming you can't get to the depth of the metadata?
Yeah.
Because in alternate products, they'll make inference because they don't have the knowledge. So it's like, hey, if we know we're going to a known malware destination, okay, great. That's probably bad. We're inferring some things, or just certain types of communication. That's the other side, is because assuming that you can't actually decrypt the traffic, or you're not filtering it off to Gigamon or something like that, which I've seen people do in the past as a means of kind of funneling traffic around. Curious, approaches there.
We actually are decrypting the traffic at line rate.
But if you don't have the decryption key, you don't have the certificate loaded in there. That's the part I'm talking about. You can't decrypt the traffic. What do you do in that case?
So the prerequisites for decryption, right, are the customer has to own the private key. Right? So
but I get that part. But if you don't have the private key, what level of sideline introspection or metadata are you able to garner off of that?
Yeah.
Because there's going to be traffic that we can't decrypt.
Yeah, of course. So,
but there's also a lot of traffic we can't decrypt. That's bad traffic.
So
that's right.
I'd just interject real quick.
Yeah.
What we find is actually a lot of the traffic you can decrypt if you have the capability, which we do. Jeff will talk about it. Our competitors generally do not have the ability to decrypt at all. So there are things you can do that basically look like traffic analysis. We do that as well when we absolutely can't decrypt the traffic. But as Jeff walks through the demo,
that's the part that I'm excited about. That part of it, and what you can do with the decrypted traffic. Removing the barriers of opaqueness.
Yeah. So you can extract some level of useful data that looks basically like traffic analysis, or as you said, if an attacker is not clever enough to use a dynamic IP out of AWS or something, then yeah, sure, you can tag that it went somewhere. But we make it pretty straightforward to decrypt the traffic, and then Jeff will talk quite a bit about what we do. So I guess what I'm trying to say is, we find actually you can usually decrypt the traffic. We don't have to fall back to just that traffic analysis very often.
On that dynamic address AWS example, just a moment. I've a number of alternate vendors in the space, just general security type vendors. They're checking when that thing was registered, and like, oh, we know that's not necessarily going to be good traffic because that website's registered as DNS yesterday or this morning or 5 seconds ago, and they implicitly weight higher and don't trust things that haven't been around for like 30 or more days and stuff like that. Yeah. Are you doing that as any type of mechanism, or you just don't dig into the depths of DNS ownership and where it was registered, et cetera?
Yeah, that's a fantastic question. So the limit of where ExtraHop's analysis, where it starts and stops, right, is within the monitored environment. So the notion of looking at, say, when a particular, let's say we identify a domain that's over 40 characters long. It looks like an algorithmically generated domain. We're not actually going out to a registry to see when was that domain registered. Right? What we are doing is looking at, say, DNS requests out to that domain, and actually have this very example with a DNS tunneling detection to alert on the fact that critical assets inside your environment are communicating with a domain that probably shouldn't be communicating with. Yeah.
Perfect. Yeah.
But I appreciate you highlighting the problem of reputation and the limits of kind of reputation-based heuristics, including threat intelligence. It gives you one kind of signal, right? If something shows up on a list of known malware IP addresses or Tor exit nodes or something like that. That's one data point that you can look at. But our view, because our system is built for scale, and we do have this ability to decrypt, that your greatest source of threat intelligence is actually the traffic that's already within your data center, right? And understanding what normal behavior looks like.
Well, I asked on that because a number of the firewall vendors you may integrate with have some of those mechanisms as detections in there as a way to mitigate and stop things.
Yeah.
I have a question for
Please.
you. One of the most difficult types of attacks to detect is an advanced persistent threat. So most of the breaches we read about, the breaking news breaches, it's not a brute force attack. They're exfiltrating data bit by bit by bit over periods of years.
Sure.
And then they become the next headline news.
Yeah.
So if ExtraHop is installed today, that traffic may look like normal traffic. What do you guys have to protect from an advanced persistent threat?
Yeah, that's fantastic.
And that's where that 4 to 5 week thing concerned me because,
Sure. So let me actually go to an exfiltration detector.
Excellent.
So when we look at the list of detections in the system and we group by title and sort by highest risk, so the scariest are on top, number 2 here with a risk score of 83 is a data exfil detection. So what we've got on our detection card here are a couple of things. First, we'll see the threat intel call out. So the red camera icon here tells us that this particular laptop in the accounting department is communicating with a peer with an external IP address. It is sent over a gig of data via SSH to this peer, and this is something that this accounting laptop does not normally do. Right, so we've got, again, the notion of a predictive model here where we have an expected value for external bulk transfer bytes out is 0, and the observed value was 1.1 gigs. Right, so there's a right there, whether it is this peer is on a threat intel list or not. Like, we've already got kind of an anomalous action.
Yeah, and let me just detail on the time frame. So the example there, the 4 to 5 weeks is what helps you understand the baseline, where we say we don't expect that this device is going to be doing things like this. So we'll start detecting right away when that exfiltration occurs. Now, as you mentioned, APTs, they don't generally try to slam in through the front door by knocking on everything. They generally go lower and slower. This is where the anomaly detection becomes so critical, is that even low and slow, it still is different from the rest of its peers. It's different from its historical behavior. And so it gives us that opportunity to say, I don't know, this is unusual. And we can raise a detection. Some of the indicators that Jeff talked about help enhance it. If that site it is going to does come up on one of those threat intel sites, it immediately gives you more context. But regardless, with those APTs that are being more clever, we'll pick up things like lateral movement. We'll pick up things like strange transitions between privilege boundaries. Even if they're doing them quietly, they still end up being unusual.
And how much hand-holding do you have to do? Because any type of system that you install like this, you have to tune it for your environment, because some of the behaviors, it could be management software, it's doing a lot of pings that could look like it's a threat. And so a lot of people assume they can install a system like this and that it's just going to work perfectly in their environment.
It's Nessus, OpenVAS, and Qualys installed in your environment.
That's right.
Yep.
You want to tackle there? You want?
Yeah, absolutely. So any vendor that rolls in and says, buy our magic Blinky box because it's powered by unicorns and you don't have to do any tuning, is selling snake oil, right? And in addition, user training, right? Anyone that says like, oh, all the users can use this on day one, right? These are complex pieces of technology. You're trying to analyze massive data sets and really kind of push the limits of what's possible with analysis, right? So this notion of applying machine learning to network data, where there is no training data set, right, that you could use, right? Where a PC acts differently in every environment, or an EC2 instance acts differently in every environment. There's obviously going to be some tuning. So the two most common mechanisms for tuning the ExtraHop system include what we call custom parameters and detection hiding or detection suppression. So it's very common for the ExtraHop system when it first gets plugged in to pick up on the Qualys scanner, for instance, or pick up on some sanctioned red team activity or a tabletop exercise, right? Because the behavior is consistent with what an attacker, what an adversary would be doing. But it's very simple to say, all right, we actually expect these types of attack-looking behaviors to come from these machines, and so don't pollute the feed of detections, or don't send a notification about that event to an analyst to create a ticket automatically, so on and so forth.
Okay.
So that's the type of tuning that's required. The other one that I would say that's actually incredibly powerful is this notion of grouping devices together. So it's a simple concept, but just to illustrate it very quickly, when we click into to the assets part of the product, we can go into device groups, and let's see if I have. I don't have the ability to do it in the public online demo here. So I'm going to switch to my other system and show you there. So creating a dynamic device group and specifying different filter criteria, we can actually create groups that if any member actually pops into the group, that itself represents something like an indicator of compromise. So if we say something like software version does not equal Windows, and role equals domain controller. Right, this is actually a fun. We can actually also do software equals Linux, right, for instance. So we've created a group with those two criteria, right? And for folks that might be familiar with the DC sync attack, right, where say a Kali Linux box impersonates a domain controller to try to trigger AD replication, right? We actually have a detector for that as well. But just by creating a group and grouping devices together in kind of novel ways, we can actually fire alerts on any time those complex set of criteria are matched, right? So that's another common example of tuning the ExtraHop system.
And,
yeah, please.
And do you, out of the box, have a pre-baked set of those complex criteria?
We do.
Like that example right there?
We do, actually, yeah. And so those are actually, we have some that we actually will create internally at ExtraHop and ship to our customers. But then our user community is also creating them. And so you can actually import a set of those device group definitions from other ExtraHop users and bring them into your own system. Sorry?
Is there like a marketplace for that?
Yes, we call it the ExtraHop Bundles Gallery. So it's sort of like ExtraHop's app store for customization packages that include things like alert definitions and dashboards. And I haven't forgotten about the dashboard question.
And customers can create and upload their own?
Yep, absolutely.
I have one final comment.
Please.
So one of the questions we always have, yes, but what does it cost? Well, the average cost of cleaning up a breach that's on the headline news, well, according to the statistics, it's $3.2 million. I would say that is way low, because it's not just the cost of the breach, it's the cost to the reputation, it's the cost to Wall Street. So when you look at a product like this, you can't think, what does it cost? you have to think, what will it cost me if I don't have it? So I just wanted to mention that.
Although in the most recent one, they paid fines of 4 cents per user. And it's like, oh, thank you. My information's worth 4 cents, I guess. I'll buy yours. I got a nickel. Give you a little extra.
You have
But
pretty
depending
good credit.
upon-
I'll give you 8 cents.
It's a bidding war going on here.
I was going to say, depending upon the level of coverage the company attempted, the fines will be higher or lower. So definitely
Well, and the
worth
one
having
of,
coverage.
this notion of fines and the problem of dwell time is really a problem that we all have to come to grips with, right? So the fact that average dwell time is measured in months is ridiculous. right?
Approximately 220 days is the average. That's the number I've been using for, at least a decade or so.
Yeah, that's right. And so if you go back to like why is that, right? And our view is that this notion of only relying on logs as a data set, only relying on endpoint, right, represents this massive blind spot for what's happening along this east-west corridor, right? And so in order to address that, right, being able to deploy a sensor along that east-west corridor that's able to analyze all of the traffic, and then apply, decrypt it, right? Parse out the protocols. So I don't think we mentioned this yet, but ExtraHop supports somewhere in the neighborhood of 60 protocols. Essentially, any language that a modern workload might be using to communicate with something else, either on-prem or in the cloud, and then. That's sort of our playground from which we're extracting packet metadata, then applying the machine learning models that Corey talked about to that data set. The output is what you see here on the screen. So I've got two more examples of detections. I want to talk first about the DC sync attack, which I alluded to a second ago. This is the case where something that's a fake domain controller is trying to replicate with one of your domain controllers. And so when ExtraHop finds this, we present it to the user in very clear terms. So you've got the attacker machine, which we call the offender. You've got the victim machine. And we've got the notion of the time series data that created the predictive model that then sort of broke against what we observed happening in the wild. ExtraHop expected this IT admin's workstation to initiate replication with domain controller 01 exactly 0 times. Right? And we observed it happen exactly 1 time. And so in order to detect this kind of behavior, you've got to understand, and we'll speak in very concrete terms here, not just what is normal, air quotes, for in general for both of these machines, the domain controller and the workstation, in terms of, say, top protocols they're talking or top peer IPs that they're talking to. But you've got to have a baseline for literally every behavior, right, that is observed between, this machine and everybody else it's talking to. It just so happens that the specific behavior we've picked up on here is a particular MSRPC call called DRS UAPI get NC changes, right? So that's the one that triggers the replication. So a very deep level of analysis that's being done there that for which the entire content of a packet is eligible, right? Not just the headers, right? So we're able to essentially do arbitrary payload inspection. Yes, you have a question there.
Yes, I do. You mentioned as far as packets and headers and metadata around the packets and the packaging of that. Are we actually collecting full TCP dumps of all the packets so we could replay back all traffic?
Yes.
And durations of time of how long that's kept, yada yada.
Yep. So let me go through a quick workflow example. So
I asked, because competition, blah blah blah. We capture all packets and keep them for X days.
Bazillion years.
No, not that long.
And that's where many
Because that's all the traffic in your infrastructure.
right.
Oh, go ahead.
Yeah. So this is actually we have this novel approach to solving what we call the data gravity problem, right? So you mentioned big data before. In some ways, it's not a perfect metaphor, but you can think of ExtraHop as doing big data analytics, but without the need for you to stand up a data lake and throw tons and tons of storage at it. And so the reason why that's the case, the reason why we have these 3 separate appliances is because they're each storing a different data set. So we have in a single system, and I'll show the click path here in a moment, looking at metrics, which are the bits of extracted metadata we've talked about a lot. And then we've got complete transaction records, which give you a log-like view, but don't require ingesting any logs. We're actually stitching together those attributes of a conversation into a transaction record. So it's a wire data generated transaction record. And then we've got the full packets, the packets of record that made up that
Can I
transaction.
ask one question?
Please.
Is it possible to zoom in a little bit on some of those parts?
Yeah.
That was my.
I've been
Great.
pinching the screen for a while and I just can't get it to be any closer.
I
Let's do it. So,
gave up on looking at it because I can't see it.
all right.
Ah, thank you.
There.
Between that and the stuff on the left side, I was just curious, like there's,
Oh, poor Drupal.
Poor Drupal. So we like to pick on the Drupal content management system here at ExtraHop. So we've got a detection here for, and this is an interesting one because it's based on a CVE. It's a remote code execution vuln that impacts only Drupal versions 7.x and 8.x. And what we're able to present here, because we are looking at the full content of the packet, because it's not opaque to ExtraHop, because we're doing the decryption on it, that we can see not just the IPs that were involved in the conversation, but what specific URI was associated, right? And even beyond that, what was the form field that the attacker filled out and submitted that would trigger the RCE, right? And so here, this is what would show up in your ticket queue as an incident ticket, or maybe in your inbox, or as an alert or a notification. And so we've done the detection. Now you're as the SOC analyst, you want to investigate this thing, right? So we provide guided investigation steps. If you were in the driver's seat, what's the next thing that you would want to see?
So can you click that? Are you going to click that and show us?
I am. Yeah.
Okay, there we go. Because you'd be like, what would you do? Next slide.
Right. And tune in tomorrow for. So we're dealing with metrics here, right? So we're going to move from that data set to the associated transaction records. And we're going to zoom out a bit here. For this one, we'll just
We'll zoom out while zooming in.
zoom in on the browser. So what we're looking at here is the actual single HTTP request that was submitted by the attacker. And what we so you see, the server is web Drupal 01. You've got the client IP address, which matched a threat intel list of known malware IPs. And what do you see here in the payload field? Right, you see the exact base64 encoded payload that was submitted to that post render form field. Right, so this is what actually, when it gets decoded by the Drupal server, ends up triggering the RCE vuln. And so now you've got a record of that interaction, and from there you can drill in one more click to the actual packets. So these are the 17 packets that made up the HTTP request and response, right? And you can click download PCAP. Now, if this traffic had been encrypted, and let's say it had even been encrypted using TLS 1.3, right, where perfect forward secrecy is mandatory. You can't opt out of it. ExtraHop would have actually provided the keylog file for you to download along with the packet capture, so that you could look at that offline in
nice.
Wireshark or another.
Or Wireshark.
Wireshark, always Wireshark.
I was going to say Microsoft Message Analyzer. Anybody?
Or Wireshark.
or Ethereal? Ethereal? Anybody?
Yeah, Ethereal, yeah. Or text edit, whatever.
Yeah. So this is a 3-click stepwise view into the 3 different data sets in the ExtraHop system. So going from metrics to records to packets. Because each of those data sets has a different footprint on disk, the retention periods vary, right, by data set. So a typical ExtraHop deployment, you can expect to retain metric data for a minimum of 30 days. We typically see a couple of months. But think in terms of weeks to months is the retention period. For the transaction records, larger footprint on disk than metadata. So a typical ExtraHop deployment will store records for days to weeks. And then for packet data, right? Largest footprint on disk. You can expect to retain full packets for hours to days.
Yep. And if you want to retain it longer, you have a mechanism to tie it off to some external
Save it off the
storage
box,
system.
stick it on your SAN. Yeah.
Yeah.
Yep.
Drop it at S3, whatever, something
Yep,
like that.
that's right. Yeah. So all of the different types of data in the system, even though those retention periods apply to, say what lives in the system based on the amount of capacity you've allocated in the ExtraHop solution, we make all of this data. Expose it to you via our APIs, so you can pull the data off the system and stick it in your own long-term storage of your choice, retain it as long as your organization requires or you like.
100 years, yeah.
And
100 years.
one
yeah.
question.
Yeah.
Okay, talking about the integration with the other systems outside your platform. For example, I think in many companies there are some organizations that are creating some incident when something happens, and then will generate, for example, a task on, for example, Jira or
ServiceNow ticket.
ServiceNow, whatever. Have you ever integrated this? Have you ever some experience?
We have, yeah. So we keep using this word integration, right, in a couple of contexts. One of the types of integrations that happens in essentially every ExtraHop deployment is some kind of ticketing system or event management system integration, right? So we actually do this in a fairly unique way as well. We don't want to replace your ticketing system, but we want to have two-way communication between our system and the ticketing system. So here's actually an example of that, where this detection event regarding suspicious SMB client file share access has generated a ticket in a ticketing system, and you can actually see the ticketing system has reported back to ExtraHop what the incident ticket number is, who the assignee is, and what the status is.
Oh, good.
Yeah.
Yeah, I got it.
And that all updates dynamically. So when, let's say the assignee changes, right, the current assignee is reflected. When the status goes from in progress to closed, you can actually see that reflected in real time. And even from the ExtraHop view of the world, know if any action was taken when the ticket was closed or no action was taken. Yeah.
Good.
Yeah, good question. All right, so I know I'm getting down to the end of my time. I want to. What other questions are out there?
Let's just clear up the whole thing with the encryption. You guys are clearly doing something to decrypt data, right? Regardless of whatever protections the customer has.
So
Yeah, that's a leap.
So we definitely need to clear this up. So our view is
question.
that there is so much analytical value in decrypting traffic that it's worth doing. But there are a lot of our competitors that are not able to decrypt traffic will seem to take the view that decryption is dangerous. You're going to run afoul of regulators. You're going to run afoul of auditors. You create a lot of business risk if you decrypt. We strongly disagree because our system is designed to enable users to not only decrypt data, but do it safely, wrap controls around it in terms of, say, RBAC or different access policies for, say, who can download a PCAP, right, or get the encryption keys, right? So all of those things are very tightly controlled, and our customers have been decrypting the traffic that they're feeding to our system since we've unveiled that feature.
And let me, I think what you're asking. So you don't have to. We do not brute force decrypt. We have a couple of mechanisms. One of the mechanisms we use is you can upload your RSA keys, for example. Okay. We also support integrations with products like F5, where they can forward us the session key. We also have our own agent that you can install so that, and it's a very lightweight agent, but who was it with agent fatigue? It really is lightweight, but it's a lightweight agent that will solely forward us those session keys. But you don't have to do any of that. We're not going to break the encryption. When you use our encryption, we're out of band, and we have the keys. As Jeff mentioned, we're very conscientious about the RBAC around them so that you can secure them. But we don't engage in some of the techniques you'll see where people, they say, oh yeah, we can decrypt, but what they're really talking about is putting a man in the middle or something. We don't support methodologies like that. Does that get it, what you were asking?
Yes, thank you for clearing it up, because it wasn't really clear. I mean, it sounded like, of course, you would like customers to decrypt. Okay, but that's not the same as...
Jeff didn't even dive through, and we are getting close to time, but one of the great examples, because the encryption question tends to be not the gotcha question, but I mean, it's the obvious question. Whenever anybody comes in and talks about, we listen on your network, it's, well, what are you going to do when it's encrypted? So one of the things we walk through is showing like an attack on a SQL server and all the commands that were happening and such. And it normally, what it kind of highlights is we certainly could, just by doing the traffic analysis, say there's a lot of transactions going between this database. It's unusual, maybe you should investigate. But if you have the decryption, we can actually see that somebody's walking the tables, somebody's dropping tables, somebody's doing this, that, and it allows you to be much more effective in your response. So we always approach it with, you don't have to decrypt, but let us show you what you can do if you do.
So I've got two questions. One, how do you integrate with something that's using rolling keys, that's constantly changing what the keys that they're using for decryption are? And then the second question, let me hear that question, the answer first, and then we'll get to the second question on it.
Sure. So there's two ways to load keys into an ExtraHop system. Let's say we're just talking about RSA keys, right? Mm-hmm. You can do it manually, or you can do it programmatically. Okay. So for customers that are frequently rotating their RSA keys, we'll essentially have a REST API call into the ExtraHop system that rips out the old ones and replaces them with the new ones.
Perfect. Now the second question is, or the disclaimer, I'm not a troll. I'm not trolling on this question, but Kubernetes. If I was trying to, and it actually tied back to the encryption part, if I was using something like Apparato, and Apparato is rotating my keys every minute, and I've got this thing, and all my service mesh objects are all talking to each other, and I'm constantly changing those keys and detecting stuff. Mm-hmm. What's the integration point where we can actually go and inspect the traffic, blah, 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 hashtag Kubernetes. Yeah.
Yep.
Here we go.
Yeah, no, great question. So fundamentally, the mechanism is no different. So one of the things that we don't have today is a direct tie-in to a key store. So something like a vault or things like that, or an HSM if we're in the on-prem world. But that hasn't proven to be really a barrier to our customers accomplishing this. Because, again, they can essentially script the key replacement in the ExtraHop system, so that as they're generated on the new version of the container that spins up, and provided the deployment hasn't changed in terms of packet acquisition, then when the ExtraHop gets a copy of those packets, it also already has the keys it needs to inspect. Now, one thing that I'll add is, Corey alluded to the agent notion around decrypting forward secure traffic. Mm-hmm. Now, we're the only vendor that we're aware of that does not do any sort of SSL intercept in order to decrypt forward secure traffic. So everyone else needs to sort of insert themselves in the middle of the conversation between the client and server, impose on the end user the burden of managing these dummy certificates, right? Mm-hmm. And ExtraHop has said, all right, this is architecturally kind of nuts. So we're going to do something different. Philosophically, we're always going to remain out of band, right? So you're never running your traffic through the ExtraHop system. You're mirroring a copy of it to the ExtraHop system. So the analysis is happening on that copy of the traffic. And so what do you do if you can't do SSL intercept? So this is where we've developed Corey used the dirty word agent. I'm going to use the term session key forwarder, because that's really speaks more concretely to what the thing's actually doing.
So it's agent.
But it's an agent.
Oh, no agents, but that sounds great.
It's not a gateway.
Right, it's not a Tumba, right? So the reason why we call this thing the session key forwarder is because it has one and only one job, which is to hook into the crypto stack on a machine. That might be S-channel on a Windows machine. That might be OpenSSL on a Linux machine, and watch for those ephemeral session keys to get generated, and when they get generated, securely transmit them to the ExtraHop Discover appliance, which is doing the packet analysis. And so that's how we're able to essentially receive the packet from one hand, receive that ephemeral session key with the other, and now we've got what we need to continue to decrypt those flows, without having to be inline. So you had a question?
I mean, you kind of went there. I was thinking from a container perspective, the agent. Where does that agent live? Obviously, is it going to be in all the images in the image, or when the container spit up, or actually on the host?
Yeah.
Or are you tapping into the CNI, anything like that? How is that?
Yeah. So typically, it's baked into the container image.
Okay.
Yeah.
Okay.
Yeah.
And that makes sense. And then you can use the keys, like you went back to Vault, you can use those encryption keys and stuff like that from that perspective?
So we cannot tie into Vault. So that's
You
not,
would like to.
that's not something that we're doing currently.
Gotcha. Okay.
Yeah.
But maybe down the line, if not Vault, something like Vault.
We get asked occasionally for
can be
HashiCorp
very
and things
hard.
like that.
Yeah.
So we haven't gotten a critical mass yet, but we're always listening. And it's obvious. I shouldn't say obvious, but it feels like it will be something that we'll want to do at some point, especially as that becomes a more standard deployment method for our customers.
But that's an easy solve.
Well, I'm not an engineer, so everything's easy.
But yeah.
Our R&D team will probably clarify that.
Yeah.
Right click, enter, we're done.
That's right.
YAML.
Yeah,
Just
yeah.
typing.
Yeah,
It's all just
exactly.
typing.
A quick question. I think you mentioned earlier that transit gateways you're still working on. But what if it's not an AWS mechanism? It's some sort of other, say, for example, Aviatrix is one example where the traffic is encrypted between VPCs. What do you do then? Also, for example, or NSX. So do you have integrations? Can you intercept traffic or detect?
Yeah, so I can take that one. So the challenge with that question is not actually the decryption part of it; it's actually the packet acquisition part of it, right? And so, this is sort of the age-old dilemma of how do you get east-west traffic when we define east-west as, say, two VMs talking to each other on the same vSwitch, and their traffic never touches a physical network, right? Mm-hmm. So there's a couple of options here. The first one is, it is possible to deploy virtual editions of our appliances right onto the hypervisor. So that's one option. More commonly, what our customers will do is lean on the capabilities of a network packet broker vendor. And all of the major ones have some sort of virtual network tap, which if we're talking about, say, a VMware environment, the architecture is essentially a service VM that's listening, promiscuously to all of the traffic that hits a vSwitch, and then tunnels that traffic out of the hypervisor to, the packet broker appliance, where it can then get passed downstream to a set of tools, including ExtraHop.
So you're talking like
Literally, that's the only real way it's done in every other scenario where people are doing that type of activity.
Yeah, and so that would show up if a person used, say, VMware on AWS.
Yeah, absolutely.
Mm-hmm.
What about capturing traffic where containers are talking to each other on the same host?
Yeah,
Same type of idea?
Yeah, great question. So this one is actually, it certainly would be accommodated by the network packet broker vendors. Their solutions allow you to essentially sniff traffic from a container to container basis, but we actually see less of a need for that in the marketplace. So, we get the question a lot of, how do I acquire every last packet from my Kubernetes environment, let's say. And most of the time when we kind of dig in, what we find is what's really important to be observing is not container to container traffic within the same pod, but all of the traffic between two pods, right?
Right.
Well, unless your application stack is within a pod. I mean, because you could have a web server and a database server within the same pod.
You could.
You could?
Yeah.
But you shouldn't. You shouldn't.
Just saying.
Deploy.
Things people shouldn't do that they do.
And customers do weird things for weird reasons, but the question that I would raise to that customer is, is your biggest problem that you need to be thinking about how to mirror those packets out of that one pod, or should you not be putting all your eggs in one basket?
Right. Yeah.
Can you tell?